13.8 billion years ago, there was absolutely nothing. And then, in the very next fraction of a microsecond, literally everything. Welcome to The Explainer. Today, we're venturing to the absolute limits of science to uncover the universe's ultimate origin story. We're going to translate some of the most bleeding-edge cosmological research out there into a visual journey.
Okay, to really wrap our heads around this mind-bending paradox, we have to recognize a pretty wild fact. 13.8 billion years ago, all space, all time, energy, and matter, they simply didn't exist. There was literally no where for anything to be, and absolutely no when for it to happen. And then, bam, the universe explodes into being. But, that begs the ultimate question. If the Big Bang created the universe, what on earth caused the Big Bang itself?
So, what exactly existed before time itself? Well, to even begin answering this seemingly impossible question, we first have to build a rock-solid understanding of what we actually know happened. Because to look before the beginning, we really have to push our current laws of physics to their absolute breaking point.
All right, let's start with Section 1, the standard cosmic timeline from the Planck era to recombination.
Picture this. Before the laws of nature even solidified into what we know today, the entire observable universe was packed into a space trillions of times smaller than a single proton. Crazy, right? This is the Planck era. We're talking just 100 million trillionths of a second after the beginning. It was this chaotic, unimaginably hot environment, ruled by an unpredictable rolling quantum foam. Basic concepts like length and time, they completely lose their meaning here.
To truly grasp what happened next, a brief phase called cosmic inflation. Imagine folding a piece of paper. If you fold it just 42 times, it actually gets thick enough to reach the moon. Fold it 90 times, and it's wider than the Virgo supercluster, which is 13 million light-years across. Well, in the early universe, space itself underwent exactly this kind of exponential doubling. It doubled in size 80 to 90 times in a millionth of a second. That incredibly violent, rapid expansion, that is what truly put the bang in the Big Bang.
Now, from that violent expansion, the cosmos finally began to cool down. It went from a chaotic plasma of quarks into a universe where the first stable protons and neutrons could actually form right around the 1 second mark. But it took a full 380,000 years for the universe to calm down enough for the very first stable, transparent atoms to form. And in cosmology, we call this huge milestone the epoch of recombination.
But here is the wild part. All that normal matter forged in those early moments, the protons and neutrons making up stars, planets, and, well, us, it's practically a rounding error. It accounts for a mere 5% of the entire cosmos. The rest of this cosmic pie is completely invisible to us. About 27% is mysterious dark matter, acting like this invisible gravitational scaffolding. And a staggering 68%, that's dark energy, a totally unknown force that's actively pushing the universe apart.
Also, in the intense heat of that really early universe, fundamental forces like electromagnetism and the weak force actually blurred together. Think of it kind of like a spinning coin in the air. The heads and tails are moving way too fast to tell apart. It was only as the universe expanded and cooled that this unified superforce broke apart, allowing the coin to finally land and reveal the distinct laws of physics we operate under today.
Okay, so with all these massive numbers and extreme conditions, you might be wondering, how on earth can physicists speak so confidently about events that happened billions of years before Earth even existed? I mean, how do we know this isn't just incredible guesswork? That brings us to Section 2, Echoes of Creation, where we actually find the baby pictures of the universe. Meet the cosmic microwave background, or CMB for short. Remember that epoch of recombination I mentioned, 380,000 years after the Big Bang? Well, when the universe finally cooled enough to become transparent, a massive flash of initial light was released. And get this, that ancient light is still traveling through space right now, just stretched out into microwaves. It's essentially a physical baby scan of the cosmos. It shows the original hills and valleys of matter that would eventually collapse under gravity to form the galaxies we see today.
And you know what's funny? The greatest cosmic discovery of the 20th century was almost chalked up to bird poop. Seriously. In 1964, two researchers at Bell Labs kept picking up this persistent radio hiss on their giant horn antenna. They literally climbed inside with scrub brushes, completely convinced the noise was caused by pigeon droppings caked inside the equipment. But after meticulously cleaning it all out, that 2.7 Kelvin background hiss remained. They had unwittingly discovered the literal afterglow of the Big Bang. It was a happy accident that actually earned them a Nobel Prize.
Fast forward to today, and our instruments are peering deeper than ever before. Observatories like the James Webb Space Telescope are looking so incredibly far into the past, they're finding impossibly bright, fully formed galaxies from just 280 million years after the Big Bang. This is absolutely thrilling because it directly challenges our long-held textbook assumptions of exactly how quickly the early universe assembled itself.
But that makes you think, right? Every time we establish a textbook cosmic fact, new observations force us to ask if we're missing a massive piece of the puzzle. I mean, if fully formed galaxies shouldn't exist that early, what else might we have wrong?
Let's explore that in Section 3, Cracks in the Model. These are the fresh anomalies currently challenging textbook cosmology.
Take the newly discovered Big Ring, for instance. Standard cosmological models insist the universe should be relatively uniform on massive scales, capping structural sizes at about 1 billion light-years. But the Big Ring is this twisting structure of galaxies spanning 1.3 billion light-years across. It's a cosmic leviathan that completely breaks the rules. According to standard theory, it simply shouldn't exist.
And it doesn't stop there. The very force pulling the universe apart might actually be shifting. The old assumption was always that dark energy was a constant, unchanging feature of empty space. But recent data from the Dark Energy Spectroscopic Instrument, or DESI, hints that dark energy's repulsive effect might actually be weakening or decaying over time. If that's true, the universe's acceleration might eventually slow down, or, wildly enough, even reverse.
So, if our standard model is showing these massive cracks, from giant cosmic rings to decaying dark energy, it really opens the door for us to radically rethink the ultimate boundary of our knowledge, namely, what caused the Big Bang.
Which brings us to Section 4, Before the Beginning. We are now venturing far beyond the reach of the standard model.
Check out this radical new theory by Dr. Richard Liu. He suggests we might need to replace the idea of a single Big Bang with a series of rapid, invisible cosmic flickers, or many bursts of creation. These sequential mini-bangs would inject matter and energy into the cosmos in rapid pulses. The crazy part? This could mathematically explain the accelerated expansion of the universe without needing to invoke the mystery of dark energy at all.
Or we could look at string theory, which paints a completely different, incredibly violent picture. Imagine our universe is just a 2D sheet, or a brain, just floating out there in a higher dimensional hyperspace. If our sheet were to collide with another floating universe, the immense kinetic energy and heat of that impact would spark a massive explosion right across our sheet. To us, living inside that brain, it would look exactly like a Big Bang.
Then there is the mind-bending work of Nobel laureate Sir Roger Penrose. His theory, called conformal cyclic cosmology, argues that our Big Bang was not a definitive beginning at all. Instead, it was a transition point. He proposes that when an old, dying universe expands until all its matter decays into nothing but cold photons, it completely loses its sense of physical scale and time. Mathematically speaking, the cold, empty end of an old universe looks exactly identical to the hot, dense starting conditions of a new one. And if theories like eternal inflation hold true, our Big Bang is really just one tiny bubble in an endless, foaming ocean of universes. Physicist Brian Cox actually points out that if there are an infinite number of universes, well, our universe's perfect, life-permitting balance isn't some miraculous accident. It is simply a statistical certainty. Every possible combination of the laws of nature absolutely must exist somewhere out there in the multiverse.
So as we push our telescopes to the very edge of the observable universe, we are left wondering. Sir Roger Penrose actually believes we might eventually find faint, circular scars hidden right within the cosmic microwave background, the literal shock waves of a previous universe's collapse echoing into our own. As we gaze into the night sky tonight, we have to ask ourselves, are we looking at the absolute beginning of everything, or just the latest chapter in a story that has been going on forever? Thank you so much for exploring the edge of knowledge with me on this explainer.